In the prior video, we showed you how you could connect a temperature sensor to the 328. This temperature sensor that we had there in the prior video is connected to port C bit number 0. We also have a graphics screen connected to the 328. So what we're going to do here in this program is to read the temperature through the ADD converter and then post the value to the graphics screen. But we're going to do this graphically. So as the temperature goes up, the graph goes up, and as the temperature goes down, the graph will go down. And this will all be done graphically as opposed to showing you the value or the number from the temperature sensor. Since we're using the graphics screen, I have included the subroutines for that graphics screen right here with the include. Now I'm ready to use the graphics screen. So let's get a little bit of that work done. The first thing we need to do with that graphics screen is to do the initialization. LCD 64 underscore init, and this will initialize the ports for the graphics screen. This initialization is done once before you go into any looping. Then when you go into the looping, let's do an infinite loop. Or, I'll tell you what, let's not do it. Let's do a for loop, and we're going to loop 128 times because that's the number of pixels in the X direction for this graphics screen. So I'll say for int x equals 0, x is less than 128, x plus plus. This is the pixel number in the X direction. We will then do a LCD 64 underscore xy. This is going to display that pixel. We're going to say display x, display y, and then the color is going to be a 1, which is an on. Well, we have the x value. It's 0 through 128. The y value is going to come from the ADD converter. So in this loop, we're going to say int y equals ADCH, because that is the register for the ADD converter. This will have the value from the ADD converter. That value will be between 0 and 255. This screen only goes up to 64. So we have to divide by 4 to scale it down. So in other words, we will say y is equal to the y value divided by 4. That'll take a value that is as big as 255 divided by 4, and it will become as big as 63 here. So 64 times 4 is 256. It's a 4-to-1 ratio. That's the scaling we need. This ADD converter works pretty quick. This will return a value within a millisecond. And if we delay it for a millisecond, it'll take that long. And this screen will take a few milliseconds. So what I'm saying is this whole process could take perhaps 5 milliseconds. We could get, that would give us 200 numbers per second. And that's pretty darn quick for the temperature. We don't want to capture data that quick. We don't want to capture 200 pieces of data per second. We would like to maybe capture the data once every minute, perhaps, or whatever time frame you would like to capture data for. So what you're going to need to do is do a delay for a minute, an hour, a second, whatever is appropriate for you. And you need to make that delay subroutine, which I will put like this. But I haven't made that delay subroutine, at least not yet. So I can come down here and make the delay subroutine, say void delay underscore 1 minute, 1 hour, whatever. And then hit enter, curly brackets. And what would go here is the appropriate delay, which I'm going to forego right now. but at least I have that subroutine made. I'm going to copy the first line. Whoops. I'm going to copy that first line and put it as a prototype before the main program. So there is the prototype. Again, the prototype is the first line of the subroutine put before the main program, and then you append a semicolon to it. Now at least this will compile. It won't really delay, but it will at least compile. So again, we're collecting 128 pieces of data. It's going to take a minute for every piece of data. That'll be about 2 hours, which is maybe a nice time frame for collecting temperature data. You get the Y value from the ADCH, scale it down to the screen size, divide by 4, and then you post it as a pixel. Well, there's more we need to do, and that is we need to initialize the ADD converter, and that's 3 lines of code. First line will be the DIDR0 equals something. The ADMUX is equal to something. And thirdly, the ADCSRA will be equal to something. And we have to fill out these somethings. The first one says you need to disable the digital input for every port C that you're using on the ADD converter. And what channels are you using for the ADD converter? If you're using every single channel, then you could put a 0B 001, 2, 3, 4, 5. Let's see, that should do it. 1, 2, 3, 4, 5, 6, 7. One more. That could work if you're using all of the 6 channels. But I'm only going to use the 1 channel. So what I could do is I could just use the 1 channel and say, okay, disable the digital input on PC0. So use PC0. Some people here put a 0x3f, and this will just catch them all. And, you know, it's overkill, but you could do it. The MUX. The MUX selects the channel that you're using. So you put in a 0x20 here. This 0 right there identifies the channel that you want to talk to. So if you want to talk to channel number 1, you put a 1 there. If you want to talk to channel 2, it's a 2. But the channel that we wish to use is PC0. Lastly, the ADSRA should be something like this. 0xe0. If you want to continuously read data. So this starts it and runs continuously. If you want to start and read once, use 0x C0. So again, if you want to do just a one-time reading, I would recommend using a C0. If you want to read forever, use an E0. And that is what we're going to use. I just compiled it and it shows no errors. So here you go. Here is an example of using the graphic screen and writing pixels to the screen. And also it shows you how you can initialize the ADD converter and then read the ADD converter using 8 bits and using that number as the value to light up a certain pixel on the screen. If you wanted to, you could take the Y value here for the temperature and instead of dividing by 4, you could post it to an LCD text screen and then you'd have the actual number that you read.